What's up, people? Hey, hackers, the whole nine. Welcome to the fourth live stream of the Codex Project, I believe. We are going to, keep working on this project and make it a little bit more full, because we right now only have one cipher on it, and we need to actually start, getting to more development, because now we got the parser working, we got the main.py file working, and the Caesar cipher working. So we're going to need to incorporate colors and some good or better UI, and then we can start incorporating everything else we want to incorporate into this. So where did we leave off? I always forget. So if we do a Python 3 and then our main.py file, it prints out the arguments. All right, so we're going to have to fix up this argument menu, make it look a little bit better. But according to this argument menu, right, we can do a Python 3 main.py, and we can do a tech C for Caesar, then we can do a tech E to encrypt, and then the text we want to encrypt will be hello, and we can use an encryption key of 5. And there you go, we got the MJQQT, so it does encrypt, decrypt, and brute force, which is pretty cool. I guess we can either start the Vigenere today, or do a bunch of tweaks today, and kind of finalize. Let's start the Vigenere. Who am I kidding? Let's have some fun. But we need to figure out how to do the Vigenere cipher. Now, a really cool thing that this website that I was, looking through when I was doing some research for this project is that they have a lot of basic examples of incorporating cryptography into Python, right? So if you go to roadmap and then Vigenere Cipher, which is the one we're working on, this is basically the entire quote-unquote roadmap on what we're doing and how it's going to work and all that other fun stuff, right? So we are working on the Vigenere Cipher, and it basically relies on the index of each letter within the key to encrypt a certain set of text, right? We start with this chart, right? So each letter, A through Z, has an index. So A has an index of 0, B has an index of 1, C has an index of 2, all the way to Z having an index of 25, all right? Now, we will have our encryption key, right? In our key, we're literally going to make our key the word key, K-E-Y. Each letter within the key has an index, right? So K, right here, has an index of 10, E has an index of 4, and Y has an index of 24, right? So when we have our plain text, we're going to call our plain text encrypt, because this is what we're encrypting, right? Again, each letter has an index, right? So E's index is 4, N index is 13, C's index is 2, etc. So when we come to the point where we're going to encrypt this text, we have our plain text, and we have the indexes for each letter in the plain text, right? So E has an index of 4, N has an index of 13, etc. Now we have our key, and we're just basically going to take our key, and then for each letter within the key, or for each index within that key, we're going to be adding that index to these indexes, right? So again, our key has index of 10, 4, 24. So we're just adding 10, 4, 24, 10, 4, 24, 10, all the way down until we have added it to the indexes of our plain text. Then we have these new indexes from the values we added together. And then this is our ciphertext from these new indexes that we got. So the index of 14 is O, right? So the index 14 right here has the letter O, which would be O. And if you follow that process, this would be the encrypted word, oribisand, right? And to reverse this, you just do the opposite, right? You have your ciphertext, then we get the indexes of each letter, then we just subtract the key, get these new indexes, and then match each index to the letter. That's how the Vigenere cipher works. Alright, hackers, so let's check out some of the cool stuff that you guys have been putting in the self-promo section of the Discord server. If you want to join the Discord server, it will be linked in the description as always, so you guys can join that. But let's go ahead and check out some of the cool stuff you guys have been throwing on there. So I'm thinking that we should start making a very base model of the Vigenere cipher, and from there we can just incorporate it into all this other fancy stuff for the parsing and CLI and etc. I mean, like for our arguments, we'll have the tag E to encrypt, the tag D to decrypt. Yeah, but you can't brute force Vigenere. It's more of like you can find the key and decrypt it from there. I mean, I could use the same tag B for that, but I feel like there's a way cooler acronym. Did I say acronym? I meant argument. I don't know why I said acronym. All right, we're just going to stick with the tag E and tag D for now and worry about it later. All right, you don't really need any additional arguments other than the key. We're going to make this look a lot cleaner eventually. Oh, careful, they may arrest you for that crypto suite. It's some OP stuff. It's gonna be. I can't even lie to you. But no, with the Codex Project right now, I'm just getting the basic functionality in so you have like a base version. But there's going to be some pretty cool stuff in here. I know there's some certain ciphers that you can actually figure out the key based on how the cipher is ciphered. So hopefully through the powers of Python, I can actually do a lot of those mathematical processes to discover keys and then automatically decrypt the cipher. I'm also going to have like hash detection and then have it automatically use Hashcat to like brute force hashes and like a bunch of other cryptography stuff. So it's going to be really cool. So let's see if we can actually get this encrypted Vigenere working. All right, you know what we're going to do? We're going to forget about this entire file. We're going to go ahead and in our resources, we're going to make a new Vigenere. I'm going to just call it v.py. And in this v.py file, we're going to attempt to make a working V cipher. All right, that's the goal. And we just need to make a basic version of the cipher so it can work enough to the point where we can use it in our other shit. So let's figure out how we can do that. This code is just turning out to be a rabbit hole. Yeah, low-key though, I'm gonna just make another file for another thing that doesn't matter. Now, I'm going to go ahead and basically just drop this in here. So if we were just to run this file straight up, it wouldn't work. And I know it's not going to work, but we're going to try and run it anyway, because that's how we roll. So if we run this Python 3 v.py, there we go. Yeah, see, look, they have a tab error. Like the tabs are so freaking messed up, dude. All right, time to reformat. All right, cool. So let's do a Python 3 v.py. How can we get the encrypted message is the letter I. Look at that. So something here is wrong, and we're going to have to figure out why. What? So this should be working. Oh. Oh, wait. There you go. Oh, this is the basic implementation of Vigenere Cipher. So we fixed this. Okay, we're going to separate this. We're going to have an encryption function and a decryption function. Cool. What is next, people? What is next? Getting the arguments to actually run this. Let's try it. Can we cd into ciphers and then Python? Oh, this wouldn't work, would it? Because we have the, why is this that argv1? Get opt is the parser gets 2, right? Yeah. Oh, because of os.system. Got you. So let's see if we can add tag v for vision. There. We do our elif, and then we're capturing our cipher option. And then we do an equals to tag v. Then we can do an os.system python 3./ciphers. Then our Vigenere Cipher.py, and then our string arguments. So technically, everything for the Vigenere cipher is set up when it comes to the main.py file. And just do a Python 3 main.py tag v. All right. Oh, did I mistype it in the main? I probably did. Yep. Okay, so we can run the Vigenere file and the tag v works, which is great. What we need to do is make sure we're getting those arguments and then passing them in. int attribute has no attribute upper. Where do we have that specific? Yeah, we made this an integer because this is not an integer. Oh, there you go. Why are we using a key of 5? Let's use pizza. Oh no, it's just not working. Never mind. Okay. Oh, we don't have attack D because we don't have an encryption process yet. So attack E. Yeah, dude, that works. It's the IPHR. Let's get the decryption process and then documents because everybody loves documentation. All right, so all we're doing is the minus equals and then the modulus equals, right? This plus equals, we're just changing that to a minus equals, and now we have a decryption. That's really it. So if we go here and run the TAC V by itself, we'll get the help menu for Vigenere ciphers, right? If we go onto this, we do a TAC E to encrypt, we'll get the text of hello, TAC K, and then we'll use, I don't know, pizza. Then we get MKKO. We need to decrypt the encrypted word, which is MWMKKO. And then if we run this, we have hello. There you go. So it works. It works. That was pretty straightforward, getting the encryption process and decryption process. So yeah, I think we're pretty much done with the basic Vigenere cipher. But again, I think next stream, we're going to try and do this like hard cipher, I guess, right? Where we're going to try to figure out the key from how they encrypted the cipher, then use that key to decrypt the cipher and get it. That's pretty cool. Right now, we have a working version of the encryption and decryption processes. So what we're doing now is we're incorporating something very specific to Vigenere, and it does work within some sort of other ciphers, but this process alone is specific to the Vigenere, where you can figure out the key piece of Vigenere if you don't know the key. Through this, you would basically have to know the length of the key, but with Python, we can just iterate through several lengths of keys, right? And by using letter frequencies, which is basically like how common each letter is, you can basically get the key and decrypt the text. So we found a program that could help us do that, and I was having a lot of trouble trying to figure out how it works, so that it didn't work. Turns out this does work. You just need to incorporate a long enough string for it to work. So we have this giant line, right? Let's encrypt this. So we'll just do like hello as our key. So now we have an encrypted lorem ipsum. So we're going to decrypt. Okay, yeah, see, look. So the key length is most likely 5. The key is hello. And this is the text, right? So it actually does work. The problem is that it only works on, I guess, strings longer than a certain length. Well, you know what? We're just going to restart. So literally all the progress we made last stream, forget it. We're restarting. So this does work. We need to focus it so that way we can only get the parts that focus on decrypting. So let's try to incorporate this, see if we can get something working, right? The TAC U is a ciphering option. Decrypt unknown key, and then here you say known key. All right, sweet. So we have a TAC V for the Vigenere, the TAC U. Our TAC I is going to be our proof of concept.txt, and then I guess we can just have it output. Well, there's no K, right? Let's go! So it's not getting the key, but the key went through and printed this. What's the file we're inputting? Okay, what if I input the output.txt file? See if it's actually working. Yeah, it's not working. It got the key though. Yeah, so let's Control L, and all we're doing here is saying we want to use the Vigenere Cipher. We have an unknown key, and we're inputting the output.txt file, which is just the encrypted Vigenere Cipher. If we check it out, output.txt is just encrypted text. If we were to run this, there you go. So the key length is most likely 5, key is hello, and then the decrypted content. Sweet. I'm gonna end the stream here so I can kind of decompress and record the video for Monday, which should be pretty cool. It's a USB rubber ducky payload, and you probably already saw my GitHub already. I made it public. I always do that, just make them public. But you can check out the GitHub, you can check out the code I just uploaded, and we will get back to work on this either next Friday or later in the week. We'll see. But yeah, so make sure to leave a like, subscribe, and do the whole YouTube algorithm thing, and I'll see you guys in the next one. So stay happy, stay positive, and as always, happy hacking.